Mount Etna slips again. Just 8 days, 4 centimeters gone. Is the Mediterranean ready for what comes next? Beneath the calm blue surface of the Ionian Sea, something deeply unsettling is unfolding. Long before most of Sicily woke up, at exactly 4:23 a.m., fisherman Jeppe Teresi felt it, a faint vibration beneath his boat. In a region shaped by fire and earthquakes, tremors are nothing new, but this one felt different. Was it just another passing shiver of the earth, or something far more serious? Scientists soon delivered a startling answer. Mount Etna's underwater foundation is moving, and not in the slow, abstract way geology is often described, but right now, in real time. Measurements revealed that over just 8 days, Etna's submarine base slipped by 4 centimeters. 4 centimeters may sound insignificant, but when that movement comes from more than 1,200 meters beneath the Mediterranean, what does it really mean? And why is it happening now? For researchers, the data triggered immediate concern. Similar movement patterns appear in geological records from around 8,000 years ago, a time when a massive underwater collapse likely sent tsunami waves racing across the Mediterranean. Could Etna be repeating a chapter from its own ancient past? And if so, how much warning would anyone have? The unease deepened as scientists detected more than 37,000 micro-earthquakes slicing sideways through Etna's eastern flank. These tiny quakes map out hidden fractures, old pathways in the rock that are once again becoming active. Were these cracks always there, quietly waiting? Or is something new forcing them open? Across Sicily, monitoring centers shifted tone. Language once reserved for worst-case scenarios now appears in daily briefings. The idea of a Mediterranean megatsunami is no longer just theoretical. If Etna's slow slide were to suddenly accelerate, could coastal communities have minutes or only seconds to react? Above the water, Mount Etna still looks majestic. The sea still glitters in the sun. But beneath that beauty, pressure is building. The question no longer feels abstract. What exactly is happening under Mount Etna? And how far could its consequences reach across the Mediterranean world? To understand this moment, we must examine Mount Etna's persistent motion, steady yet unstoppable, like a living colossus frozen in geological twilight. For years, researchers logged minor shifts, registering changes so subtle they existed only in the records of sensitive instruments embedded deep within Etna's flanks. The movement seemed glacial, a process meant to play out over thousands, perhaps tens of thousands of years. Recently, however, this calm narrative was upended. On Sicily's southeastern edge, near the restless boundary of land and sea, advances in underwater sensing have revolutionized what we know. Seafloor probes, left to monitor subtle ground deformation, eventually registered dramatic results. Etna's vast southeastern underwater flank underwent a sudden 4-centimeter shift in a span of only 8 days. This was more than a tremor. It was a measurable lurch in the foundations of a volcanic giant. To put this into human terms, imagine an entire city moving the width of your fingertip, not over years, but in a little over a week. The scale of such sliding, for a structure as massive as Etna, is beyond ordinary experience. It has the power to reshape the very contours of Sicily's eastern coastline, and to send tremors through the towns and villages that huddle in the volcano's shadow. Despite its slow pace by human reckoning, Etna's trajectory in geological time is startlingly swift. The volcano moves not through the classic mechanism of a slow landslide, nor by timeless, imperceptible drift, but as a dynamic whole. Edifice, flanks, and foundations together respond to the internal press of rising magma. Each intrusion of molten rock acts as a wedge, prying apart the eastern side of the volcano, producing fractures and encouraging further creep toward the sea.
This migration is not simply an incremental slide, but a process poised for abrupt change. Ancient lava and volcanic debris spill into the sea, carving the coastline, even as the same energy feeds the region's celebrated fertility. Between the olive groves and vineyards, the Greek temples and Roman ruins, lies the quiet evidence that all this land is built upon a foundation in motion. Modern science has peeled back the layers of mystery to reveal black, seismic scars, fractures opened along bygone lines first carved during catastrophic collapses thousands of years ago. New seismicity, logged in detail year after year, exposes a lattice of weakness running deep below Etna's eastern edge. More than 37,000 microquakes have been recorded, each one a signal of shifting rock, each one sketching the outlines of pathways into which the mountain may someday collapse. So what does this portend for Sicily's coastal life? It's easy to worry about eruptions or falling ash, but the more enigmatic menace is this barely perceptible sideways motion, a foundational drift that silently imperils everything built above. While a city may someday recover from fire or lava, a shifting foundation may offer precious little time or opportunity for human response. Is acceleration inevitable? Might some as yet unrecognized combination of seismicity, magma intrusion, or hidden weakness convert slow creep into sudden collapse? Those are questions science cannot fully answer. The clues remain deep beneath the sea, locked within deposits and fracture zones left by previous cataclysms. Thousands of years before the invention of modern monitoring, the Mediterranean was shaped by a disaster still discernible in geological record. Roughly 8,000 years ago, a sudden submarine landslide unleashed tsunami waves that swept across portions of the sea, abruptly ending the lives and settlements that lined the ancient coasts. The physical evidence is there, lying amidst disturbed seabed sediments and in the abrupt, jumbled layers of marine debris pushed across the Ionian floor. These layers reveal that an event of extraordinary violence occurred. Material shifted over immense distances, the kind of upheaval that only a rapid, massive collapse can explain. While current research most often links the disaster to submarine flank collapse, possibly involving Etna or another regional volcano, the details of the culprit remain a subject of ongoing study. Along the margins of the Ionian basin, archaeological traces mark ancient disruption. Settlements and simple fishing communities that once thrived along the shore abruptly vanished, their artifacts sealed beneath sand and debris delivered by an overwhelming wave. Ancient hearths left abandoned, abrupt changes in local vegetation reflected in pollen records. These are the imprints of a catastrophe that transcended memory and entered into myth. Oral histories echo the trauma. Stories of towns devoured by the sea, legends of gods and monsters conjured in response to disaster. Modern scientists continually cross-reference these narratives with fresh geological evidence, tying legend to rock and rock to history. The persistent question remains, could such an event repeat? Today, as tiny earthquakes ripple beneath Mount Etna's submarine flank, and each fresh centimeter of movement is measured and mapped, scientists wonder, could these patterns signal a new wave in the making? Could a single submarine slip set off a sequence ending in disaster? The risk, now well studied, is not visible from land. It gathers strength in the obscured dark, where water and rock quietly plot the next move. Those ancient waves teach a sobering lesson. Major Mediterranean tsunamis need not announce themselves with warning. Sometimes, the disaster comes from below, initiating a cascade that can erase entire communities in the span of an hour.
In modern times, with Sicily vigilant and science advancing, new observations fuel both knowledge and concern. Data from 2025 have confirmed what earlier suggestions hinted. Mount Etna's foundation is less secure than previously believed. The numbers are daunting. Over 37,000 microquakes have been traced across the eastern submarine flank of Etna, mapping not random tremors, but focused, organized swarms along known lines of weakness. These align with ancient fault zones, the very deep roots believed responsible for the cataclysmic collapse millennia ago. Submarine surveys, using advanced sonar and pressure sensors, detect new fissures appearing at 1,200 meters below the sea. Every fresh measurement brings new perspective, subtle boundary deformations that could prelude something much larger. The images returned from these depths show scarred landscapes, ravines carved long ago, boulders and sculpted seabed marking the history of earlier flank failures. Shockingly, the 4-centimeter slip registered over 8 days is no longer an anomaly. It's a clear demonstration that Etna's edifice, hitherto thought capable only of languid, predictable motion, can move in sharp, unpredictable bursts. Rather than a steady, glacial process, these findings reveal the potential for sudden acceleration, acts as dramatic as anything remembered in oral history. Sicily's officials respond with growing urgency. Risk managers, volcanologists, and geologists pore over new data with each instrument update. Critical here is the realization that magma is the engine for instability. As it rises, it forces apart the flanks of the volcano and exacerbates the weaknesses hidden beneath. Recent breakthroughs have made a difference. Scientists have developed a simple seismic earthquake index. By monitoring the pattern and frequency of microquakes, they can better predict magma ascent beneath the volcano. This signal is now part of Sicily's expanding early warning arsenal. The people of eastern Sicily watch closely. From Catania's harbors to the rocky coves of Aci Trezza, ordinary life is overlaid with real-time updates. Alerts, school drills, and civil protection exercises now part of the annual rhythm. Even fishermen heading out into the pre-dawn Mediterranean wonder if the next gentle tremor is only the beginning of something much greater. The region's readiness is tested with new urgency. Evacuation plans are practiced, tsunami drills added alongside fire and earthquake routines. The serene beauty of Sicilian shores is now seen through the lens of scientific caution. Is Etna's submarine collapse an eventual certainty, or is there still time to intervene? To probe the full danger, we must descend not only physically toward the ocean depths, but also conceptually into the mechanics of moving mountains. Mount Etna's southeastern flank, abutting the Ionian Sea, teeters on the edge between stability and collapse. What recent research has illuminated is sobering. Etna's submerged foundation does not rest on firm, ancient rock, but on a patchwork of clay, volcanic debris, and silt, each layering over millennia, each susceptible to slippage, their surfaces lubricated by water and further weakened by geologic stress. The volcano's interior, alive with hydrothermal fluids and rising magma, destabilizes these underlayers. Superheated water, suffused with minerals, seeps through deep fault zones, making the overlying rock layers more pliable and increasingly likely to slip. These processes, water, heat, and pressure, set the stage for seismic events that can occur with little external warning. Add to this internal brew the relentless emergence of magma. When fresh molten rock rises, it applies force unevenly along the mountain's core, pressing hardest where the flank is already weakest. Over time, fractures multiply and open wider, further prying the mountain's skeleton toward failure.
That famous 4-centimeter submarine slip was not just a momentary twitch. It reflected a convergence of built-up stress, a sharp release that hints at how the interplay of slow and rapid movement might someday combine into a much larger event. The central question remains: will future motion continue in these incremental steps, or will it someday leap in a single, devastating slide? Scientific modeling and probability studies confirm that volcanoes like Etna do not always fail gently. Flank collapses can be sudden, horizontal in direction, and catastrophic in outcome. If sufficient mass were to slide rapidly into deep water, a tsunami could be triggered and reach nearby coasts in mere minutes. The disaster potential is vast. Simulations reveal that major waves could radiate outward, impacting towns and cities throughout the Mediterranean, challenging the entire region's preparedness and capacity for rapid response. Crucially, all current evidence, mapped cracks, seismic swarms, and geodetic data shows that many conditions required for collapse are already present. The question for scientists and communities alike is not whether Mount Etna's flank will eventually fail, but when it might, and how much warning humanity will receive. While the world has made leaps in earthquake and volcano monitoring, the signs preceding a sudden submarine landslide
remain difficult to capture. The Seismic Earthquake Index, now used to track microquakes beneath the volcano, offers a precious advance. By connecting subtle shifts in earthquake pattern to the rise of magma, researchers can sometimes anticipate when pressure is building toward a critical threshold. But even the best sensors grant only minutes, or, at most, hours of notice if a full-scale submarine collapse occurs. The warning may arrive as nothing but a blip on a scientific display, a cluster of microquakes, or a sudden change in seabed pressure. By the time the signal is confirmed, there may be little time left for action. Preparedness on Sicily and across the Mediterranean is intensifying in response. Countries have expanded networks of seafloor seismometers and pressure transducers across the Ionian Basin, supplementing these with high-resolution satellite monitoring and community drills. Tsunami warning systems stand ready to issue alerts almost instantly, yet the challenge is formidable. A landslide of sufficient scale would send seismic and oceanographic shockwaves across the region in the blink of an eye. Even state-of-the-art systems may only marginally extend the time available for evacuation. Communities wrestle with this uncertainty. Is it enough to practice, to plan, to hope the critical hour never comes? Officials circulate leaflets, organize public meetings, and rehearse evacuation plans. Schools fold tsunami safety into their curricula, and volunteers identify the vulnerable, ensuring everyone knows the fastest route to higher ground. At the same time, a feeling of unease persists. Preparedness never feels complete when the threat lies out of sight. Questions persist. Will our early warning systems distinguish between an ordinary seismic cluster and the first sign of catastrophic collapse? Can silent signals truly provide the vital, final clue before the sea itself rises in retribution? Amid all of this scientific debate and official preparation, daily life continues along Sicily's eastern shore, but a sense of watchfulness pervades. Fishermen like Jeppe Teresi keep a wary eye to the horizon as dawn breaks. In towns such as Catania, conversations often begin with, "Did you feel that shake last night?" News outlets occasionally run stories of mega tsunami risk, revisiting the stories of ancient upheaval.
To many, it still seems improbable, too sudden, too immense for modern comprehension. But the raw facts are clear. Mount Etna's entire structure is acting as one immense, slow-moving landslide. The product not merely of gravity, but of ongoing, active volcanic pressure. The fractures mapped in recent years have reawakened fault systems dormant since the last major collapse, their latent power now all but proven. Local, regional, and international officials meet continually, balancing realism with reassurance as the data evolve. Sicilian children now rehearse both fire and tsunami drills, learning with each update that resilience is built, in part, upon preparation. Across the sea, other Mediterranean nations monitor the situation closely, recognizing that a natural event of this scale would respect no borders. The history of coasts, from Crete to Alexandria, Naples to the shores of the Levant, is marked by both legend and the archaeological scars of disaster. In the end, everyone who lives here understands. Life at the feet of Etna is an act of balance between risk and reward, vigilance and routine. Will the region's fortitude withstand the next true test? That question remains as open as the fractures beneath the sea. What does the future hold as Sicily faces a crisis both hidden and profound? The answer lies in the continued endeavors of scientists, residents, and leaders to respect, measure, and prepare for the unpredictable. Monitoring will continue unabated. Seismic activity will be logged, and each movement mapped with growing accuracy. Underwater equipment will try to detect the earliest hints of rapid slippage, and communication systems will spread the word as quickly as possible. The aim is no longer to deny the risk, but to anticipate and stay ahead of it. Across Sicily, awareness deepens. Teachers bring the lessons of nature into their classrooms. Children learn the dual meaning of beauty and danger, and families plan for contingencies they hope never to face. Art and memory, too, integrate the volcano's presence. Etna is a source of inspiration and anxiety, growth and threat, life and the potential for sudden change. This ancient land, perched at the crossroads of continents, must once more live with respect and readiness. The lessons of the past, and the warning signals now being recorded from beneath the Ionian Sea, insist that catastrophe is real, and preparation is the surest companion to hope. While the stars watch over the mountain, and waves wash endlessly against Etna's submerged base, the question remains: how much time is left before the secrets below shift the fate of Sicily, and of the wider Mediterranean once again? The mysteries beneath Mount Etna's submarine flank remind us that, even in a world of instant communication and advanced science, some forces move beyond our vision and beyond our control. As Sicily waits, history's depth and its dangers are never far away. Whatever happens beneath Etna's slopes may one day be written in the shapes of coastlines and the fortunes of cities